Did this potentiometer circuit confuse you? A resistor split by a sliding wire. Is this series, parallel, or something completely different? Don't worry. In the next 3 minutes, we'll crack this JEE Mains 2025 question step by step and make these current electricity numericals feel easy. Welcome to the 9th video of the Current Electricity Numerical series. Now, let's zoom into the potentiometer wire. The sliding contact is exactly at the middle, so the wire gets divided into 2 equal lengths. And we already know from the meter bridge concepts that, for a uniform wire, resistance is directly proportional to length. That simply means if the length becomes half, the resistance also becomes half. The total resistance of the potentiometer wire is 1 ohm, so each half of the wire will have a resistance of 0.5 ohms. That means the left section is 0.5 ohms, and the right section is also 0.5 ohms. Now, let us place these divided resistances back into the circuit and analyze it carefully. As you can see, the 0.5 ohm resistance and the 2 ohm resistance are connected between the same 2 points. That means they are in parallel connection. Now, let us calculate the effective resistance of this parallel combination. Using the parallel resistance formula, we get 1 upon R, effective equals 1 upon 0.5 plus 1 upon 2. Solving this, the effective resistance comes out to be 2 by 5 ohms, or 0.4 ohms. So now, instead of these 2 separate resistors, we can replace the entire parallel arrangement with a single resistance of 0.4 ohms. Let us redraw the circuit using this effective resistance. Now we have a 0.4 ohm resistance and a 0.5 ohm resistance connected in series. And for resistors in series, we simply add the resistances together. So the total resistance of the circuit becomes 0.9 ohms. Now, we can directly apply Ohm's law. Current equals voltage divided by resistance. So, current becomes 0.9 volts divided by 0.9 ohms. And this gives us the final answer, 1 ampere. Thank you for watching till the end. In the next video, we'll solve another interesting numerical from JEE Mains as shown here. If you found this video helpful, make sure to like the video, share it with your friends, and subscribe to the channel for more current electricity numericals. And do comment below if there's a particular problem you want me to solve next. See you in the next video.